So it is, one always says it's a great pleasure to do these things, but in this case it really is. I first met Don in 1975 when I came here as a graduate student. And one has some heroes from whom one learns in particle physics, and there are not very many. Don was certainly one of them. Other people, being Roger, I'm sure I'll spare his blushes by saying so, and Gunther Wolf and Bjorn Vik at Daisy. So Don was one of my very few experimental heroes in particle physics. So when John Wheater asked me, when the university were naming statutory chairs, whom I would like my chair to be named after, it took me about a microsecond to decide on Don. And so it's been my great privilege and pleasure to be the first Donald H. Perkins Professor of Experimental Physics. Although I'm now emeritus, they tell me, which means they've stopped paying me, as far as I can tell. I should give a lot of credit and thanks to Don's daughters who are here, because they've given me a lot of information which I wouldn't have been able to find otherwise. So Venetia and Michelle, thank you very much. So this is Don's career in a nutshell. I'll really be talking about this time. There, of course, is much more to come, but you will see all of those things in the next lectures. So basically, he was born in 1925 in Hull. So let's tell you something about that. Don's father and mother were both school teachers, and this is his school, which had been founded not long before he attended it, actually, so he must have been one of the first pupils. It was a grammar school in those days, in 1932. It was a tough school. So Don, no doubt, held his own. Certainly he flourished academically. He had many extracurricular activities, and the first one was his first publication at the age of 12 in the Meccano magazine. Now, in most audiences, I would have to explain what Meccano was. But in this audience, I'm sure at least all of the boys will remember Meccano. Even I remember Meccano, although I wasn't very good at it. But Don was a absolute whiz. And this is his first publication, a very tiny differential gear, as in a car engine. So this was supposed to be the smallest one that anybody had come up with, which is pretty impressive. So that was when he was 12, so that was 1937. Then he had a second publication in Meccano magazine. This one is even more impressive. This one is an aircraft locator apparatus. And this one was published when he was 16. Also at the age of 16, he was building radios, and he built a crystal radio receiver. And apparently the first transmissions he picked up, it says in one of his articles, was of some news about Converse's experiment in Rome. I find it quite hard to believe that there would be a radio broadcast on Converse's experiments in Rome. But anyway, that's what Don says in his book. But certainly he built this radio. So he was clearly a person who was extremely practical, very good with his hands, and extremely inventive. He also maintained his uncle's collection of moths and butterflies, which eventually ended up in Hull Museum. I would not have thought of him as a Lepidopterist, but there you are. You learn something every day. He left school in 1943 and had an excellent school report. Here is his report. I won't read it to you, but perhaps one extract. He has a remarkable grasp of essentials and very considerable practical ability, nor is he afraid of hard work. And earlier on it says he obtained an open exhibition at Cambridge, and this performance did not surprise us, as Perkins was clearly one of the best students the school has had. He had an offer to go to Trinity, Cambridge, where he hoped to take a science degree and then study medicine. But he was screwed by the fact that he didn't have the requisite Latin. You can tell this was a new grammar school, because in those days, everybody did Latin. I did Latin. So this school clearly was advanced and didn't bother with Latin. So he didn't have any Latin at all. And therefore he couldn't go to Cambridge. So instead he went to Imperial. And a friend of his from Yorkshire had already gone there and clearly given him the idea that it was all right. So in 1945 he graduated with a BSc with first-class honours, sufficiently high up that he qualified for a postgraduate scholarship, and then he registered for a PhD at Imperial. Now, most people's PhDs you would pass over very quickly. You would certainly pass mine over very quickly in a life story. But Don's, it turns out, was quite remarkable. And so I'll actually spend most of my time on Don's PhD thesis, or the work which was around it. So you first have to put yourself into his intellectual milieu. When Don began his research work, the only particles we knew about were the proton, the neutron, the electron and positron, and the muon. But the muon was not really understood, as you'll see. That's part of the story. But anyway, it was known that there was a particle which is heavier than the electron, a charged particle. So nobody had an idea what the muon was. Everybody thought a neutrino existed, but it wasn't found experimentally, of course, until much, much later. There was a postulation by Yukawa in 1935 that there was a carrier for the strong nuclear force, and that eventually became known as the Pion. And it should be the lightest, stable, strongly interacting particle. And today, of course, it's produced by the million in modern experiments, not per experiment. But here's an example of a heavy ion collision at RIC, which almost every one of those tracks is a Pion. But when Don started work, nobody had seen any tracks of a Pion. So what Don decided to work on were emulsions, and I'll tell you a little bit about that in his own words in a moment. They go right back to the dawn of particle physics. So in 1895, Röntgen, purely by chance, discovered X-rays and used a photograph to see what they could do. That's his wife's hand, the famous photograph from his laboratory. And another serendipitous use of photography and emulsions was Becquerel, who one day, rushing off to some committee meeting, put all of his equipment to look at phosphorescence in a drawer, one on top of the other, higgledy-piggledy, including his photographic plates. When he came to do an experiment the following day and developed them, he found this incredibly bizarre black area when he'd wrapped the whole thing in black material and put it in a darkened drawer. So he knew it wasn't light, but something was being emitted from this mineral sample. And when he looked at the shape of the blackened area and compared it to the minerals he'd placed on top of the photographic film, he could tell that this was coming from pitchblende, an ore of uranium. So this was the discovery of radioactivity, which in many ways, including X-rays, began the study of particle physics. So emulsions go all the way back. Don's supervisor was another great figure in particle physics. So we've had two of the founders. Now we go on to J.J. Thomson. So the famous particle physics joke is that J.J. Thomson got the Nobel Prize for proving the electron was a particle, and his son got the Nobel Prize for proving the electron was a wave. That always raises a laugh among physicists, even if not the rest of the audience. So here are the two people in question, J.J. on my left, or your left as well. And there is his son, GP. He was always called GP. There he is when Don knew him as a great physicist at Imperial College. So here is Don himself talking about how he began life as a physicist.
The reason I got involved, I was at Imperial College and started research there in late 45, and I had to read in an article the quotation from, I happened to read this quotation by the president of the American Physical Society that the study of cosmic rays is remarkable for the minuteness of the phenomena, the delicacy of observations, the adventurous excursions of the experimenters, and the grandeur of the influence. And so I went to the my supervisor, G.P. Thompson, the son of J.J., and I said that I like to do cosmic rays, and he actually sent me off. The first paper I read was the paper in German by Blau and Van Bach in 1938. And he said, come back when you've read this paper and tell me exactly what you want to do. So I thought, well, I realized that I had to, well, one could get emulsions high in the atmosphere, either by going to mountains or flying balloons or going into aircraft. And so I thought, well, this is a chance to get that. I've always had a wish to get to the Andes. So I went to GP and I said, yes, I've decided where I'd like to go. I'd like to do some exposures on Mount Chacaltaya in Bolivia. And he went practically ballistic. He said, we have very little money here. And if you think I'm going to spend money on sending research students swanning around the world to South America, he said, so I said, well, what do you suggest I do? He said, well, it's pretty obvious, but since you don't know, I'll tell you. You walk down Exhibition Road to South Kensington Underground Station, and there you'll find a bookshop. And in the bookshop you can buy yourself an atlas of Europe, look at the atlas and select an Alp, and don't worry me anymore. So I went down, I didn't buy the atlas, I looked through the atlas, I looked through the Pyrenees and the Carpathians and the Alps, and I found finally a place where you could get up to 10,000 feet without any effort. There was a railway all the way up, and that was the Jungfraujoch. And I'll talk to you about it a little bit more later. So that was how I got into cosmic rays and emulsions.
So I'll in fact talk to you a little bit about the Jungfraujoch. So that was Don, his lecturing style, which all of you will remember with great affection. Always entertaining and almost always full of information. So let's take ourselves back to when Don began work. 1947 is a remarkable year. It turned out that 1896, 5 and 6, were the separation between the discovery of X-rays and the discovery of radioactivity was about 3 months, which is remarkable. So in 1947, another remarkable set of things happened. So I mentioned that the Yukawa particle had been postulated in the 30s, but nobody knew quite what was going on. It turned out that there were various particles you could see in cosmic rays which penetrated down to the Earth, but they had peculiar properties that no one understood. They decayed almost completely, never interacted with matter. And so clearly they didn't seem to have the right properties to be the Yukawa particle. So Sakata and Inoue in the November of 46 came up with the two meson hypothesis, that there were two different particles. One was the strongly interacting particle, which later became the Pion, and the other was a weakly interacting particle, which later became known as the Muon. That was published in a Japanese journal and was unknown in the West for at least a year. Don certainly knew nothing whatever about it. You see, the next paper is one of his, and we'll talk about that in a second. At the same time in Italy, and this is the statement he made about looking at hearing a radio broadcast when he was young of the beginnings of this experiment. They were looking at cosmic ray particles which came down to sea level. And what they saw was that all of these particles, the negative ones, just stopped in the carbon and decayed into something else. And nothing ever happened. There were no gamma rays. There was nothing to indicate any nuclear reactions. Then Occhialini and Powell saw 6 particles like the one that Don had seen. And then in 1947, the discovery of the Pion took place, as we'll talk about now, in fact. So this is... in fact, the first of Don's discoveries. So as he mentioned, G.P. Thompson arranged for him to take flights from the RAF. In fact, Don thought for many years that it was his persuasive powers that had allowed his plates to be taken up in an aircraft. But of course, it wasn't. It was G.P. who'd rung up RAF Benson and asked them to allow Perkins to take these emulsions up to 35,000 feet, and they flew around for several hours in Spitfires, apparently, which has been quite exciting, 35,000 feet. And here is a photograph of Don. I'm at a loss to understand quite when this was. This one unusually has on the back a date, but it's extremely difficult to read, and it looks like it says 1940. But he would have been 15 then. He surely wouldn't have been smoking a pipe at the age of 50. But it's clearly a very young Don. So I suspect it was when he first went to Imperial. So anyway, there he is, looking very, very dapper. So yes, they flew these things, and then Don developed the emulsion, and he found this remarkable event, which we'll look at in a bit of detail here. This is the paper on the right-hand side, published in Nature in 1947. He did this in December of 46. So this is Don's event. It's a remarkable thing. On the right, you see the photomicrograph. In fact, there's a photograph of this in Don's thesis, but it's so faded now that you can't see anything except the tracks B and C. So what happens is that track A is, in fact, what later became realized to be the Pion. It comes in, it slows down. You can see it's slowing down because the number of grains on the emulsion that have been excited gets denser. And then it actually is captured by a nucleus, and that nucleus decays into a number of protons. So B, C, and D are coming out of the nucleus. C is going down into the screen. B and D are going out of the nucleus. You can see they're slowing down because, again, the grain density gets more dense. So A is something new. It's something which slows down and stops and then is absorbed by a nucleus and causes it to disintegrate. So Don had no idea what it was, and neither did anybody else for a long time. Until in 1946, Occhialini and Powell, who had much better quality emulsions than Don had, were able to obtain two of these events after exposure at the Pic du Midi. And what you see on the first one, on this one here, is that there's a muon, a pion coming in here, which then decays. You can see again that the density of bubbles is getting, grains is getting heavier and heavier as it slows down. And then this muon is emitted here, and the same thing happens here with a different angle. And what you do when you're analyzing these plates is you count the number of emulsion blobs per centimeter, which is proportional to the energy, and you look at the scattering, which tells you something about the momentum. And then you can work out, in principle, from Einstein's equations, you can work out the mass. And so they could work out that this thing was a mass which was around 140 MeV, and that was a new particle, and that was published in Nature shortly after Don's publication, as we saw in that list of publications earlier on. So this was the discovery of the Pion, and eventually in 1950, Powell got the Nobel Prize for that. In fact, Don had also got an event like this, which he published in his thesis from plates which were exposed for him at Chamonix by Louis Leprince-Ranguet, another great cosmic ray person of the time. And here is the picture in Don's thesis. And again, you see this pattern that the muon comes in here and slows down and stops and decays into another particle, which it turns out is the muon. So this was the third pion which had ever been seen. But Don didn't bother to publish it because he was so impressed with the Bristol results from Occhialini and Powell that he thought they didn't need any confirmation. So all he did was put it in his thesis. You know, this is the third pion that had ever been seen, but he never bothered to publish it. Those were the days. He did put it in his thesis, as I said. So that was Don's thesis, and a remarkable thing it was. Even as a graduate student, he was already at the center of affairs. This is from one of his papers describing the situation at the time. Let me just read it to you. At the other end of Europe in England, a byproduct of the war and nuclear program was the setting up in 1946 of a panel by the Ministry of Supply to oversee the development of special photographic emulsions to record nuclear particles. Those were the days when government thought that nuclear physics and particle physics was useful. The chair was Joseph Rotblat, who won the Nobel Peace Prize in '95. And there were 8 or 9 of us on the panel, including Cecil Powell, Otto Frisch, George Rochester, and Berryman and Waller, who were the chemists who developed the emulsions, both at Kodak and at Ilford. And this panel basically worked with the chemists to increase the sensitivity of the emulsions in an important way. So even as a graduate student, Perkins was involved in panels which involved at least 2 Nobel laureates, and George Rochester should have got the Nobel Prize, but never did. He discovered the V particles, which afterwards were strangeness, but no one at the time really realized for many years what they were. So here is Don finally getting to the mountains. I don't know why it took him quite so long to get to the mountains, but anyway, eventually he got to the Jungfraujoch. This is a photograph, actually one of Don's photographs of the Jungfraujoch Observatory. And he was doing various jobs at the Jungfraujoch. So here he is with a colleague actually trying to see if you bury deep into the ice, if there's some effect on the number of particles you see as a function of the depth. Apparently this experiment didn't really work. But anyway, when he was working on this experiment, he approached the caretaker of the Jungfraujoch, who spent his entire life on that observatory and didn't see people very often, and asked him if he could use some of his lead, because he wanted to melt it down and shape it so he could use it as an absorber. And this lead had been carefully worked by this guy, the caretaker, into beautiful shapes. And apparently when Don asked if he could melt down his lead, this guy went completely ballistic. And this is this guy's dog. This is one of the most bizarre pictures I think I've ever seen. This dog now seems to be completely rabid. I don't know whether it's about to bite Don, but he doesn't seem at all concerned. He's sort of watching it with some sort of extraordinary, I don't know what the word is, interest. So he had quite a few adventures in the Alps. I don't think his skiing was very good at that stage, but probably got better. So eventually this panel managed to improve the sensitivity of emulsions. And once you saw electric sensitive emulsions, the electrons are very much more difficult to see because they leave much less ionization behind them. But once you had an electron sensitive emulsion, then you could see this whole pion coming in and decaying into a muon, and then the muon eventually decaying into an electron. And then it was clear what was going on. And these are 4 pi mu e decays from the early part of the 1950s. So then things became much clearer, but this was quite a few years after Don's pioneering work. So Don left Imperial and arrived in Bristol just too late to share in the Pion discovery, but he arrived in 1849 with a scholarship from the exhibition of 1851. Apparently, according to the history of Bristol physics, he possibly also had a Royal Society Mackinnon scholarship. I'm not sure whether that isn't a mistake in Bristol physics, but anyway, it's possible he had 2 sources of funding. So a wealth of physics poured out from Bristol in the 1950s, and Peter, Fowler, and Don were at the center of it. This is the Bristol group in 1950. It's unfortunate the photographs had a bit of damage. Down here is Cecil Powell, but you can scarcely see him because his face has been somewhat obliterated. But Don is very clear and stands out very clearly there. This is about 1950. Peter Fowler was Don's sort of collaborator for many years at Bristol, and this is a younger Peter Fowler in 1930. He was Lord Rutherford's grandson. So there's Lord Rutherford, and there's Peter. I knew Peter very well. He was a delightful man, extremely, extremely bright. It was astonishing that 2 people as bright as Peter and Don were at the same place at the same time. So there they are together. This isn't Bristol, I'm not quite sure where it is. And neither do I know who the two people in the middle are. But this is Don, obviously, and this is Peter. Another thing that they did together was they were the first people to propose the use of pions in cancer therapy. That was a Nature article that they published towards the end of Don's time in Bristol in 1961. A lot of the work that Don did in Bristol was related to the decays of the charge kaon. The strangeness particles were first seen, as I mentioned, by Rochester and Butler in 1947. And these decays were particularly rich and confusing, and it took many years to unravel them, and Don and Peter played important roles in that. One of the things that they were doing was to, in addition to exposures on mountains, where the cosmic ray flux, of course, is higher, they also went even higher by using hydrogen-filled balloons. I'm not sure if this is Don. It looks like it might be Don. I remember he had a sort of dirty old duffel coat like that. And it's a sort of typical Don posture, so it could well be Don looking at this balloon going up. And of course, it was not entirely hazard-free, this balloon stuff. So here's a picture of the aftermath of one balloon that exploded. And those of you who know will know that this is John Mulvey, and this is Owen Locke, who spent many, many years at CERN. I don't remember who these two are. One is a guy called Davis. I don't know which one. Anyway, you can't tell. They're completely burnt. So it was dangerous, but they managed to do lots of very good work. One of the things, Don's first book was the Bible of Emulsions, Fowler and Perkins. Here is the first edition, published in 1959. They also went on to do many more things. This is Don's list of publications. One I would like to draw your attention to here is one which is related to the King-Perkins-Chudakoff effect. I didn't know that Don had that effect, but he does, the King-Perkins-Chudakoff effect. It's normally called the Chudakoff effect. It's a bit less of a mouthful, because Chudakoff was the theorist who post hoc decided what it was about. It's essentially quantum electrodynamics and relates to the screening of the other charge when you just produce an E plus E minus pair from a photon. Anyway, Don was the first person with this guy King to observe this, and he had a theoretical explanation which was pretty good. But Chudakoff managed to steal the thunder. These theoreticians, they always steal the thunder. So that's the Perkins effect, and I didn't know about it until the research I did for this. This is some of his later publications, and you'll see that most of them are about essentially looking at nuclear physics type effects with emulsions through cosmic rays, flux of gamma rays at high altitude, production of pions and hyperons and nuclear interactions at very high energy. And you start to see some things which are to do with beams. There's the paper with Peter about applications for cancer therapy. And down here, he spent some time in Berkeley, where the first really accessible pion production machines were being run, accelerators. And he did quite a lot of work on looking at kaon decays at that point there. But he already realized that basically emulsions were running out of steam. So by the late 1950s, he was beginning to change his field and turning increasingly to the use of accelerators rather than cosmic rays. And he had the opportunity to come to Oxford in 1965. He was recruited by Dennis Wilkinson, and he worked with Ken Allen, the other statutory professor at the time. But it was his Imperial and Bristol work which was the basis for his election to the Royal Society in 1966. So just to finish, let me show you a couple of photographs. It's always fun to look at these photographs. You can spot all of your friends. This is the 40th anniversary of the Pion conference. This was nominally chaired by Peter, and I was the secretary. So what that meant was that Peter would send me some jokes every now and again, and I would do all the work. And we used to have committee meetings, and Peter and Don were, well, Peter was nominally chairing the committee, and Don was a member. So I don't remember us ever doing any work, but there were an enormous number of jokes were told at the time. Norman will remember those committee meetings, which were by far the best committee meeting I've ever been involved with. There are lots of other people here. There's Rudolf Piles, Menon, who was a great cosmic ray person, Zakrewski from Poland, Don Davis from UCL, there's Peter Fowler, this is Rosemary Fowler, his wife. Now, Rosemary was actually was the first author on a lot of the early discoveries related to kaon physics. So she was a graduate student in her own right, very unusual in those days, and there was a very interesting article in Nature in January published by Susie Shee, which went into Rosemary's career as a physicist. Another example of women's contributions to physics, which have somehow been overlooked. Who else is there? This guy here is Waller. He was the wizard who produced all of these emulsions at the time. A remarkable guy. He was a chemist, but he came along to this physics conference and gave a remarkable lecture about how they managed to increase the density of silver inside the emulsion to therefore eventually be able to see electrons. David Binney, John Melos, well, you can spot them. Well, there's Don. For a moment I couldn't see him. Paul Murphy. A lot of good friends. David Saxon. George, you must be there somewhere. I can't see you immediately. Oh, there's John Mulvey. Anyway, enough of this spotting, but here's some more. This is slightly later, and I show this just because it's indicative of the leaders of particle physics at this time in the early 1990s. This is John Melos's retirement. There's Don and there's Peter. So this is one of the last photographs I have of them two together. Peter died very, very early. I don't remember precisely when, 2 or 3 years later. He was a great man, and Don and he were great friends. Lots of other people who you'll recognize on here. Some of us are here today, George and John. That's Robin Marshall. This was, right end was the right place to sit because most of the rest are now dead, except for Peter, who's still alive and kicking. And there's me. I've got it to the right end of the screen. And there's Roger. Who else can we spot? Greg Heath and Helen Heath. Norman was there somewhere. I don't see you immediately, Norman. Anyway, enough spotting. It's always great fun. And many great friends there, particularly great friends of Don's. He and John Melos were great friends. They used to amuse each other greatly. So let me just conclude with Don having the final word yet again. This is from another of his papers. But some things have not changed at all. 50 years ago, Cecil Powell described his feelings on finding all those wonderful new processes in nuclear emulsions. He said it was as if suddenly we had broken into a walled orchard where protected trees flourished and all kinds of exotic fruits had ripened in great profusion. Well, the walled orchards still exist today. Perhaps they are not so easy to find, but they are there, and it is for the new generation of physicists to find them, as I am sure they will. Thank you.